Hello again. Welcome to another lesson in geometry. Today we are covering section 9-1, translations. Okay, so we have some vocabulary first. Underline the correct word to complete the sentence. So a transformation of a geometric figure is either going to be a change in its position, shape, or size of the figure. So not the color. We don't care about the color in geometry. Okay. So cross out a word that does not describe a transformation. And the wrong word here is going to be erase. We're not going to erase something for a transformation. We will flip it. Okay, that's called a reflection. We're going to rotate it. That's called a rotation. We're going to slide it. That's called a translation. And we're going to turn it. That's also a rotation. Okay. All right, so we have isometry. An isometry is a transformation in which the pre-image and the image of a geometric figure are congruent. Okay, so that means all the corresponding sides are still going to be the same length and all the corresponding angles are still going to be the same measure. All we're going to do is slide it or turn it or rotate it, so flip it, those things. So here's an example. These two shapes are congruent, okay? And here's a non-example. These two shapes are not congruent. See how the size changed from the pre-image to the image. Okay, so an isometry does not change the size, preserve size. Okay. All right, use your vocabulary. Complete each statement with congruent image or pre-image. In an isometry of a triangle, each side of the image is congruent to each side of the pre-image. So remember, isometry doesn't change the size, so all of the sides are still going to be congruent to each other. In an isometry of a trapezoid, each angle of the image is congruent to each angle of the pre-image. Remember, an isometry does not change the size, so all the angles are going to be the same. Okay, same measure. All it does is turn it or flip it or slide it. So an isometry maps a pre-image onto a congruent image. So the same size, same shape, okay? All right, so we're not going to change the size. All right, let's flip it over and see what's on page 2. Okay, on page 2 we have our big problem number 1, identifying an isometry. So we're working with the definition of isometry. So does the transformation below appear to be an isometry? And we want to explain here. So this is our pre-image, and this is our image, and both of them are kites. So the pre-image is a kite, and the image is a kite. Okay. Do the pre-image and the image appear to be congruent? And this should be yes. I think they look congruent to me. All of these sides appear to be the same length, and all of these sides appear to be the same length, and all the corresponding angles also appear to be the same size. So does the transformation appear to be an isometry? And this is yes. Okay, and then a possible answer of explain could be something like this. The pre-image and the image appear to be congruent. Okay, so the transformation appears to be an isometry. All right, big question number 2, problem 2 here. Naming images and corresponding parts. In the diagram, triangle NID, and then we have a new notation here, to triangle SUP. What are the images of angle I and point D? So the arrow says transformed. So we take our image NID and we transform it up to our, we take our pre-image NID and we transform it to our image SUP. So what are the images of angle I and point D? So the arrow, the transformation arrow, shows that triangle SUP is the image of triangle NID. So NID is our pre-image. We did some transformation to it. It looks like we slid it and rotated it to get our new image of SUP. So in this case, triangle NID should be congruent to triangle SUP. because we know that it's an isometry, therefore the shape should be congruent. Okay. Describe how to list the corresponding parts of a pre-image and image. And this is going to say something like this. List corresponding parts of the pre-image and the image in the same order. And that's because we know that there's an isometry, so they're supposed to be congruent. And when we list parts of congruent triangles, because these are triangles, we list them in corresponding parts in order. So we do the same thing here. Okay. So circle the image of I. Okay. So I is here. This is the pre-image, and I went to U. Okay. So it moved around to where U is. And we can tell that from our original thing, where it shows here that I and U are both in corresponding parts. Okay. Now circle the image of point D. Okay. So in our pre-image, point D is here, and it got moved around to P. And we know that because D and P are in the corresponding parts. So this should be P. Right? And then our last thing on the bottom here, a key concept. Translation. So a translation is a transformation that maps all points of a figure the same distance in the same direction. Okay. So here was our pre-image ABC, and we map A this way. We map C the same distance in the same direction that way, and we map B the same distance in the same direction that way. Okay. So a translation is an isometry. It did not change the size of our new triangle. And we put the prime notation here. So B turns into B prime, C turns into C prime, A turns into A prime to show the new one. So if if quadrilateral PQRS is translated right 2 units, then every point on triangle P prime, Q prime, R prime, S prime is 2 units to the right of the pre-image. Okay. So if we move 1 point, 2 points to the right, or 2 places to the right, then we move all of them 2 places to the right. And that's so that we can preserve the size and make sure that this stays in isometry. Okay, on our third page, we have big problem number 3 here, which says finding the image of a translation. And what are the images of the vertices of triangle ABC for the translation? That's going to take every point and move the x coordinate 1 up and the y coordinate, 1 to the right and the y coordinate 4 down. Okay, and then we're going to graph the image of ABC afterwards. So first off, we're going to identify the original, so the pre-image. So A is at -2, 2. B is at 1, 1. And C is at 0, -1. Okay? Now, use the translation rule that moves our xy coordinates x1 to the right and the y's 4 up to find our new coordinates of A prime, B prime, C prime. So we take for A, to get our new image of A, we're going to take our old one, the pre-image, and add 1. Okay. And then for the x coordinate, and we're going to subtract 4 from the y coordinate. So -2 plus 1 will give us -1 for our new A prime. And 2 minus 4 will give us -2 for our new A prime's y coordinate. All right, then we do the same thing with B. So it used to be at 1, 1. We add 1 to the x coordinate to get it at 2. And we subtract 4 from the y coordinate to move it to -3. Okay. And the C used to be at 0, -1. We add 1 to the x coordinate to make 1. And we subtract 4 from the y coordinate to make -5. Okay. All right, circle how each point is translated. So each point moves 1 unit to the right and 4 units down. So that's this one here. 1 unit to the right and 4 units down. And that's because our transformation equation here says, hey, take the x, move it 1 to the right, and the y, move it 4 down. All right, so graph the image of triangle ABC on the coordinate plane. All right, so this is our pre-image. Our image is going to be these 3 guys. Okay, so A prime is going to be at -1, -2. Okay, and B prime is going to be at 2, -3, and C prime is going to be at 1, -5. Okay, and then if we graph this, we get our new image of the triangle, A prime, B prime, C prime. Okay, and then just for quick, we can show, hey, look at B. B got moved 1 to the right and 4 down, and that happened for every coordinate. Okay. All right, problem number 4. Write a rule to describe a translation. Okay, so the translation image of LMN is L prime, M prime, M prime, where L prime is 1, -2, M prime is 3, -4, and N prime is 6, -2. So circle the coordinate of L. So L was at -6, -1. So that's going to be this one. And then it says circle the coordinate of point M. Point M is at -4, -3. So that's this one. These are all bad. Okay. And then we have to circle the coordinates of point N. Point N is at -1, -1. So that's here. Okay. And then find the horizontal change from L to L prime. All right, so let's see. So L was at, where are we? -6, -1, okay? And L prime is at 1, -2. So the horizontal change, let's see, we went from 1 to subtract -6 will give us 7, okay? So our horizontal change was 7. All right, and then find the vertical change from L to L prime. So we start with L, which was this for our vertical, okay? And this one for L prime. So we do -2 minus -1, okay? The new one minus the old one. And this gives us a vertical change of -1, okay? All right. So from triangle LMN to L prime, M prime, M prime, each value of X was what? Let's see. It was +7 for the change. So it was increases. How much did it increase? It increased 7. Okay. And to go from LMN to L prime, M prime, M prime, each value of Y, let's see. What did it do? It decreased. It went down 1. Okay. So our formula here is going to be take the old X, the pre-image, add 7 to get the image, and take the old Y coordinate, okay, Y, and subtract 1 to get the new image's Y coordinate, so Y minus 1. So let's check that, all right? So we'll use M. Originally, M was -4, -3, okay? This was M. And we know that M prime is supposed to be 3, -4. So let's see if our formula works. If we take -4 and we add 7 onto it, it becomes 3. And if we take -3 and we subtract 1 to it, it becomes -4. So our formula did move the image of LMN to the pre-image of LMN to the image of L prime, N prime, N prime. All right, page 4, problem number 5 at the top here, the big problem, composing translations. So the diagram at the right shows a chess game with the black bishop 6 squares right and 2 squares down from its original position after 2 moves. So here's its original position. Okay, it moved here for move 1, following this thing, and then it moved here for move 2. So this is the new position, okay, after 2 moves. All right, and then next the bishop is going to move 3 squares left and 3 squares down. So the next move is going to count 1, 2, 3, 1, 2, 3 to go to here. Better pick a different color for that. 1, 2, 3, and that would be move number 3. Okay, so it's going to be a new position. So where's the bishop in relation to its original position? So we're looking at this red one for the newest position, and then the blue one up here for the original position. All right. So if 0, 0 represents the original position of the bishop currently, so this is its current, I guess is the best way to say this, is at 6 and -2. So that's 6 to the right, 1, 2, 3, 4, 5, 6, and 2 down. Okay. So write a rule, a translation rule that represents the bishop's next move. So the next move was the one where we went 3 to the left and 3 down. So that's going to be 3 to the left, x minus 3, and 3 down is y minus 3. All right, so substitute the point you found in exercise 27 into your rule. So in exercise 27, we knew the bishop was currently sitting at 6, negative 2, and it's going to move 3 down, so 6 minus 3, and it's going to move, 3 to the left and 3 down, so negative 2 minus 3. This will put our bishop at 3 and negative 5 from its original position. So let's count that up and make sure it makes sense. So from the original position, I move 1, 2, 3 to the right, and then 1, 2, 3, 4, 5 down. So that's right compared to its original position. All right, lastly, we have a lesson check. So as always, pause your video, okay, and then come back after you've tried it and check it over. All right, talk to you in just a second. All right, so we have an error analysis here, and it says, your friend says the transformation of triangle ABC to PQR is a translation. Explain and correct your error. All right, so if it was a translation, then it's supposed to slide A to P and B to Q and C to R. And all of those slides should be the same distance in the same direction. All right, so if we move A to P, that's a really long move. And if I move C to R, that's a really short move. So this is definitely not a translation, okay? So find the distances between the pre-image and the image for each vertex. So from B to Q was 1, 2, 3, 4, 5. So 5 long. From A to P, 1, 2, 3, 4, 5, 6, 7, 8, 9 long. And from C to R, only 1. Okay. Does this transformation map all points to the same distance? And this would be no. None of them are the same distance. So ABC transforms to PQR. Is it a translation? This is no. Okay. Once again, the distances between the image and the pre-image points are not the same. Between the image and pre-image corresponding points are not equal. Okay, so for it to be a translation, we have to slide everything the same amount in the same direction. All right, so correct your friend's error. This transformation is actually a reflection. Okay, and we'll learn about how reflections work later, but a quick one here, quick explanation is, kind of think of this as a mirror here, and if we reflect it, then we flip this. So A flipped really far because it was far away from the mirror, and C didn't flip very far at all because it was really close to the mirror. Okay, so a reflection is a transformation, and it is an isometry because it doesn't change the shape. The shapes are still going to be congruent, but just moves it around in a different way. It flips it upside down. All right, so down here, check out the vocabulary words that you understand. So hopefully you're with transformation. Pre-image, that's the one we start with, and then we do stuff to it, transform it to get the image. And then isometry means we don't change the image at all. It's still congruent. It's just been moved around. Okay, and then a translation is one way we move it, which is sliding. So how well can you find transformation images? Hopefully you're in here. I think for a lot of you guys, you might not have done any work with transformations before other than you just see it every once in a while on the standardized testing. So make sure that you're asking for questions in class if you're having some trouble. All right, I'll see you in class next time.